Okay, good morning, welcome to
FamilyMath number 844.
FamilyMath844. So today I thought I'd show you probably one of the first really advanced proofs that you've seen that E is irrational. Before we dive into that, do you remember how the proof that the square root of 2 is irrational goes?
Yeah.
Because one little bit of the proof about E being irrational is the same, and then but 90% of it is different.
Okay.
So how does this one go?
So square root of 2 is irrational, so you assume that it is rational.
Okay.
So you can write it as a ratio.
So assume square root of 2 equals A over B.
Mm-hmm.
Okay.
Then you want to simplify it, so you multiply by B
Okay.
to get rid of the fraction.
So then B times the square root of 2 equals A.
Then you square both sides.
Alright. 2B squared equals A squared.
Yeah.
Alright.
So now you know that the number of 2's on each side is going to be different.
Alright.
Because you have, if B is odd, you'll have 1, 2.
Uh-huh.
Which means that you have to have at least 1, 2 over here, but the only way to have, you can only have even numbers of 2's on this side.
Right.
And you'll always have odd numbers of 2's on this side.
Okay. Because if B is even, B squared would have an even number of 2's, and that would... Okay.
And therefore, this can't happen.
Alright. Yep. That's a very good proof. Alright, so we're going to do something, the thing we're going to do that's similar is the proof by contradiction, and assume that E is rational.
Okay.
So we have to start with the definition. E, actually, do you know the definition of
Yeah.
E? What's it defined as?
So it's defined as the sum of, I think the sum of the inverse, the reciprocals of the factorials.
Okay.
So 1 plus 1 over 1 factorial, plus 1 over 2 factorial, plus 1 over 3 factorial, plus da da da.
Yeah, and it turns out that this representation of E actually leads to a pretty easy to understand proof that that E is irrational, which is pretty amazing actually. So we're going to do the same thing. We're going to say that we're going to let E equal A over B. Okay, and then we're going to arrive at a contradiction.
All right.
And the contradiction is going to be exactly, well, no, sorry, not exactly. It's going to be similar. We're going to arrive at a contradiction relating to integers. So A and B are integers. We can say they're in lowest term, but that doesn't matter. But E is equal to A over B, where A and B are in lowest terms, and let's see what happens.
All right.
Okay.